Just wait a minute.
Okay, we are live. Hi everyone, please wait for a second. He's just coming for in a minute.
Hi.
Yeah. So, hi everyone. My name is Manish Kumar Singh from CryptoNaukri. Today we have a special person with us, Mr. Dhruv D Jain, and he is a blockchain developer at Dorsey.io, and he's still a student, finally a student. So today he talk about Solana, how to start with Solana and writing smart contract in Rust. So, welcome to CryptoNaukri, Dhruv.
Yeah, and that's a good introduction. Hi guys, I'm Dhruv. So today I'll be explaining how to start with Solana, what Solana is all about, and how to start building on it. So yeah, I'll just share my screen now so you can see my. Just wait a minute. Okay. Is it visible?
Wait a second. Yep, now it is visible.
Yeah. So let's start with introduction to Solana. So so before starting, let me tell about myself. So I am a final year student studying engineering. So I'm currently working. So we are currently building a hiring platform that's called as a doors. So in this you can endorse people, and even you can refer people who have a caliber, who you know that needs to get a job, have skills and all. So along with that, we have a new feature, something called staking, that if you feel the person is good and he needs to get a job, you can stake on him. So that would improve his credibility and help companies get him a job. So that's what we are building. And this is built on Solana. You can just go there and check it out if you want to. Yeah. So let's start with Solana. So Solana is a layer one blockchain, like just like Ethereum, Bitcoin, and all things. And Solana has features just like Ethereum. So you can build smart contracts. You can build smart contracts. You can build DeFi protocols. You can have your own tokens like ERC20. You can have your NFTs. Everything is just like Ethereum or any other layer one blockchain. But the thing why people go with Solana is because it kind of solves the problems which Ethereum is facing with, right? So Ethereum has very low transaction speed and it has huge transaction fees as well, right? So you can say that Ethereum has like 15 transactions per second. And then normally this Web2 transaction or Visa, MasterCard and all, they can easily do up to 25,000 to 50,000 transaction per
Yep.
second. Right. So that is too low, then that is not scalable. And we have layer two protocols as well. But then still, if you want to develop on Ethereum, and then it's like you cannot scale it, right? So that's where Solana comes into play. Solana is a layer one chain, so um, it has extreme low transaction fees, and it is super fast. So it has around 65,000 transactions per second. So theoretically, it can go up to 7,20,000 transactions per second without scaling. But practically, that's how the speed is. So that's how they can go up to 65,000. But normally, practically on the mainnet, they go around 6,000 to 12,000, which is not up to 65,000, but still it's a huge leap to what Ethereum can do that, right? Ethereum can do only
Yep.
15, and 12,000 is like too much, right? That's
Yep.
it's actually 100 times better than that. And what it does is it has extremely low fees, right? It has only 0.04 rupees or like 0.00005 dollars. So that's negligible, right? If you
I,
have to
I,
spend
I
a
think,
dollar per
sorry,
transaction, yeah.
I think it is equal to the Polygon. approximate the Polygon that much charge? It is very low.
Now Polygon is like
Yep.
0.002, but this is in
Yep.
rupees, right? So
Yep.
it's like Polygon is $0.002. So this is like 100 times cheaper than Polygon.
Yep.
So this
That's
is
great.
even faster than, even better than Polygon, right? And the best part of this is, so if you have to spend $1 for transaction, you can do almost like you can do 1 million transaction, and that would only cost you $5. So that's like awesome, right? And this can be achieved because of proof of stake, and also something called as proof of history, right? Proof of history is not a consensus mechanism. It's only what you call as encryption mechanism, which they have introduced. So what other chains like Ethereum and Bitcoin does, it uses proof of work, where all the nodes start working, and the node which completes first is getting verified by other nodes, right? So there's a lot of computation, a lot of things, and it's kind of it's not so secure as well. So what happens in proof of stake is, you can see that we have 5 nodes: V1, V2, V3, V5, right? What happens is like these 5 nodes will stake some amount, like $100, $200, $300. They'll just stake into the pool, and based on the staking, based on the previous things and all the nodes will choose one node. So what happens, like in this case, V4 is a node which is chosen to verify the block, verify the transaction. So what it does is, only the V4 block verifies it, and all the other nodes just no, V4 block does a computation, and all the other blocks just verify it. So this is a very efficient mechanism to do the transactions and all, right? It doesn't take a lot of computation power. It only takes little bit, and the proof of stake is related to the volume of the blockchain, right? So since people have to stake on it, the more volume it has, the more money the hacker has to put to gain access to more than 51% do an attack. So the thing is, the more value the blockchain has, the more safer it is. So, what is proof of history? So, what it does is every 400 milliseconds, the node gets changed. So, what happens, like after 400 milliseconds, V4 V4 goes to V3, and then V2 does the calculation. And after it goes to V3, it keeps changing. But how will it prevent other nodes from maliciously skipping some part and then doing their part? So what happens, like if suppose it is V3 is V3 nodes part of doing the calculation part, but V3 is skipped by V5, and V5 does the calculation. Other nodes will still verify, and they'll just say, okay, yeah, done. You can move on, and V5 will get the rewards. But actually, V3 should get the rewards, right? Because it was V3's turn, and this is solved by proof of history. So what happens, like there's a timestamp saved in all of the nodes, and they will choose which node has to do the computation part. So from that timestamp, they can verify if V3 was supposed to do or V5 supposed to do, and then other nodes which were not supposed to do, they will be then just discarded, and they will be slashed. So if the stake was $100 will be gone, so they will lose the stake. So this is what the proof of stake is and proof of history is. And proof of history is only related to Solana. So it's not a consensus mechanism. Proof of stake you see in many other chains, right? You see in Avalanche and other chains. So you also see near protocol and all those things. Proof of stake is common, but proof of history is only with Solana. So this is how Solana is super fast. And since it doesn't use a lot of computation power, the fees are also very low, right? Yeah, so we'll move on to, yeah. In Solana, the smart contracts are called as program. It's still smart contracts only, but then in Solana, they just thought of calling it as programs. So if you see any reference to programs, they are smart contracts. So we'll keep using programs instead of smart contracts. But if you come from Ethereum background, smart contracts, programs are just smart contracts. That's all, nothing else. And then in Solana, the smart contracts can be written in any language, any low level language. It can be written in Rust, C, C++, and then it can even be written in Move, which is a new language developed by Facebook, which is developed on top of Rust, but basically for blockchain. So even that can be written, even that can be used to write the Solana programs. But mainly people use Rust because there's a framework called Anchor, which is written in Rust and makes the development super easy. So that is awesome. And then because there's a lot of boilerplate code if you're writing um, without the app framework. So there's a lot of serialization, deserialization, passing the accounts, so much of things. So that can be simplified by using a framework. Or else if you want to try with C, C++, you can do go, but then there's a lot of boilerplate code you have to write, and then doesn't make sense to write all over again. Yeah. So then let's go to the Solana program architecture. I mean, the Solana smart contract. So this is new. Solana programs are stateless. That means the programs don't store the data. Unlike the programs in Ethereum, the data and the smart contracts are bound together. So they are bound together. So they are together. So each smart contract uh, and the data are binded together, right? Bound together. But in this, so what happens in Ethereum is, there's no upgradability. So once you deploy the program to mainnet or testnet or somewhere, if you want to edit the code, you find that something is missing and you have to edit the code, you cannot do that. You cannot upgrade. Upgradability is not possible in Ethereum chains, right? That's because since the data and then programs are together, that makes it impossible to do that. So what you have to do is you have to upgrade the program. You have to deploy a new program with a different ID, and then you have to replace it everywhere. So in a decentralization point of view, that is actually better because once you write the program, nobody can edit it. So nobody come from outside can come and can edit it and then change the architecture of the program. So that's kind of good in one way. But then if you launch a program and it has some bugs, it has some things you need to change, you need to upgrade it somewhere, you should have new features, you cannot do that. You have to go to new, what do you call it, you have to go to new uh, a new program ID and then you have to deploy it. So but here's where Solana shines. Solana programs are stateless. That means Solana smart contracts and data are two different things. So these two don't stay together. Data is stored in a heap, and then the Solana programs are separate. They're stored in accounts. Yeah, so this makes the upgradability possible. So if you are writing a Solana program and you deploy it, and you find that, oh no, I have some error, or you want to upgrade, you have to change a feature, you can of course do that. And it can only be done by a particular authority. So if I wrote the program, I have the authority to do that. So in a decentralization point of view, that is actually bad. But then if you have a DAO which controls who if you should upgrade or not, that makes it decentralized. So that is actually better. So that's about Solana programs which are stateless. Yeah, and then all the memory is inside the heap. So that means that all the so there's a global heap, and all your memory, that means your accounts, your Solana accounts, your SPL token programs, and then your memory, everything is stored in a heap. So you can if you see the image, you can see that there's a heap, and there are programs which are on top of each other. So what happens is like each program is identify the program ID. So this is a global heap, and then this is what makes Solana fast, right? So what happens here is since everything is bound together, it doesn't have to search everything. So whenever you're making a call from the client side that I need to run a function, you specify the accounts you need to read or write. So what Solana virtual machine does is it only takes a part of the heap that the program wants to access. So if there are 100 to 200 accounts, it will only take that 10 accounts which the program needs to write or read. So that is taken aside, and all the heap is not touched. So what happens there is it so it differentiates differentiates the accounts into different columns. such that these accounts are not overlapping. So what happens is, like, if there are 10 accounts and five accounts don't talk to each other, they're independent of each other. Those five accounts, those transactions can happen parallelly, right? So what happens, like, just if you take an example, there are 10 accounts. Each account transaction takes 1 second. So if I do it sequentially, what happens in Ethereum and other chains, they happen sequentially. The transaction happens sequentially. So if one transaction takes 1 second, then all the transaction will take 10 seconds. But if they happen parallelly, if they're not overlapping, of course, if they happen parallelly, then all the 10 transactions, if they're non-overlapping, they can happen in just a second. They can run parallelly and they can happen in seconds. That's like, so in Solana, so the same program in Solana takes 1 second, but same program if it done sequentially, it takes 10 seconds. So that's like super useful, and that makes it super fast with this. Okay, so you need to know this by writing the smart contracts because this is helpful. Yeah, so this is what I was talking about. Solana programs run parallel in runtime. So you need to send the program which accounts you would be need while running the function. So you need to tell that I'm using these accounts, and these accounts, some will be read, some will be wrote. So so the program makes sure that if these accounts are non-overlapping, they will run parallelly. So if there are two accounts, one is for reading and one is for writing, these two don't intersect with each other, right? They don't overlap. So they can run parallelly. So that makes it super fast. Yeah. So this is what Solana is and Solana architecture. You can actually learn more about Solana on their website, or even go through the frameworks articles and all. So you'll get more information on this. So let's start building. So what we want to build today is we'll build a ticket platform on Solana. So what will happen is we'll have three functions. So we'll have a venue function, ticket function, and purchase tickets. So what will happen there is, a person has a venue. They'll come and create a venue, and then that person can come and even create a tickets over there. So if you consider a real world example as a concert, so I chose a stadium as a venue. So I'll go to the website, create a venue, and then I even create tickets. So there might be two, three types of tickets. Like there might be some front row, back row, middle row, and side row, VIP row, and all those things. You can create multiple tickets, and I can have multiple different price for each ticket. So one ticket costs $100, other ticket costs $200, and those things. And while purchasing is what users will do. They'll just go, they'll mention the quantity, and they'll also mention the amount of um, amount of tickets they need, and the price and everything, right? So if I want 10 tickets, I just go transfer the amount for 10 tickets and get it in my wallet. So that is what we will build it. Let's do that now. If you have any doubts, you can just pitch in.
Hi, Dhruv. So I have a question. So which tools do we need to start with Solana? Tools or the just just like in Ethereum we need Remix ID.
Yeah, so the thing is, you have to install the Solana toolkit, but
Okay.
now I think it will take a lot of time. But if you have it installed, you can just go start away with this. You have to install this. This is Solana CLI, right? And then you can
Okay.
do all kinds of stuff with that. But if you don't have that, you can use a playground. Soul PG, yeah. So if you don't have anything installed, you can
So
create a
it is an
project.
online ID
Yeah, yeah. So it's
playground.
called
Okay.
beta.soulpg.io. So if you don't have the Solana environment and the Anchor framework which you're gonna use, yeah. So this is a new framework which they have built it recently, Seahorse. So if you just search for it, just a minute. It's a framework written in Python. So what you can do is, if you're not familiar with Rust and all, you can start away with Seahorse, develop programs in Solana with using this Python. I mean, this is a great website and this is a great framework. I mean, it's still new, but still, if you want to try it out, you can try it out. It's nice. Some people have also built a machine level things on top of this, so you can of
Oh,
course try
that's
this.
great.
Yeah, and then and if you want to try here, you can just try here. But I have not tried the Python version. But for now, you can just click Anchor, choose the name of the project, so I'll say Educate, and then create. It will give a basic template for you, and then we can just start working on that. Okay. Yeah, but right now I'll do it in my machine. So yeah, yeah. So we will be using the Anchor framework. You need to have the Anchor CLI as well, along with the Solana CLI. So what we'll do is we'll just do Anchor in it, and it will create a new project for us. We need to provide the name as well. So it will create new environment. It will create a Rust file for us, and also create a test file where we can call to the smart contract and do the test as we want. So let's wait for that. You also need to have yarn installed because these packages are installed using yarn. You can go to this Anchor website and you can install this. So you can work around with this. This is actually a brilliant framework. Almost all the programs on Solana are coming on to Anchor, and then this is actually brilliant because it doesn't you don't have to invest a lot of time in serializing, deserializing, writing all those boilerplate codes, parsing these accounts and everything. This does all of the things for you, and this documentation is pretty good. And then I mean, it's easy if you are, I mean, you don't need a good Rust knowledge as well, right? Because if you're just starting with native Solana, you know each and everything, and then that takes a lot of time. But fuck. But this Anchor framework makes it very easy, and I surely think you should try with this. Yeah. So let's start with this. Let's create an account for that. So we are creating an account. So this is a structure. So this will contain all the information we need to create a venue. So I would need the name of the venue. That would be a string, and then I would need the venue ID. Uh, string, and then we would need tickets available. Tickets. So this could be vector. Vector is just like an array, but this is dynamic. In array, if you like, the size of the array would be fixed, but in vector it is dynamic. So the data is stored in heap. You should be aware of not utilizing a lot of data because that costs a lot, and it makes the program slower because it's in heap, right? Heap is slower than accessing from the stack. So we'll have an structure for that. Um, yes, we'll also have the person who created this owner of this venue. So that would be a pub key. Okay. Yeah. We should so we'll make a structure. Yeah. So the structure, so the ticket will have the ticket name, of course, and then we'll have the price. So we use 64, and then we would need the tickets available. If it is 100, 200, 300, those things, right? Yeah. Okay, we should also have some traits. Let me check what all traits do we need, because as far as I think, let me check. Okay, I'm not sure about this. Let me have a look. So the traits is what makes it. So traits are something like as what I can say, like since Rust is not an object-oriented programming, so Rust is like having properties which can be shared between different structures. So here, this is a structure, and this needs to be serialized, deserialized, and there are a couple of things which needs to structure to be. So that we need to have it here. Let me check what is it. You can pitch in if you have some doubts. Sure, I would be happy to help. Yeah. So these are the things we need. So I'll just copy this and explain what these mean. Okay. So these are the things. So the thing is, these are some traits which are needed for the structure to work in the global storage. So we have a debug. So having the debug, so the thing is, so we are using Anchor framework. So Anchor framework wants us to do some expects us to provide these things so it can do the all the underlying serializing, deserializing things. So it requires us to use Anchor serializer and Anchor deserializer, and also requires a clone. So what happens like clone is whenever you copy a variable, it actually doesn't copy, it only references the address, right? So it's not copying, it's only referencing the address. So if you change the variable on the copied one, the original variable will also be changed. But when you use clone, what happens like it creates a new memory for it. So that makes it so the original variable and the copied variable, clone variable are not related. So that is why you need the clone. Yeah, and then debug is used for using some debug related functions like the dbg, or like something related to that, or even printing the whole structure as well. So for that you need the debug trait, and these are some of the things which Anchor expects us to do, so we have to do that. You can also refer to the documentation if you want more info regarding that. Yeah, so let's start by having a list of accounts we need to create a venue. We'll have this. So we will be using something called PDAs, which are defined as program derived addresses. Yeah, let's go to that PDA and then understand. Okay. Yeah. So let's understand what PDAs are. So let's suppose I want to have a program. I want to have an account which will store the. So let's take an example. So there are two people, Alice and Bob. So Alice and Bob need to exchange two tokens. So Alice has token A and Bob has token B. Yeah. So then Alice and token need to swap the token without having a middleman. How would you do that? What you can do is you can store this Alice account, Alice tokens inside another account that is controlled by the program, right? So what happens is like Alice transfers the token into the other. We can call it as an escrow account. Transfers the token into the escrow account, and then Bob pays it directly to the Alice. So what the program does is it checks if Bob has paid to Alice or not. So as soon as the Bob pays Alice, the tokens from the escrow are released automatically to Bob. So what you have done is you have swapped the tokens between Alice and Bob without having a middleman. Since escrow account is governed by the program, is controlled by the program, so it runs as per the program is written. And then the main thing about PDA is it's an public key only. So it's called as program data address. So PDA has seeds. So PDA is something called as an address which doesn't have a private key. So the PDA cannot be used to sign the transactions. So what happens, like whenever you derive a public key, so there's 50% chance that it can lie on the ED2559 curve, and it can have a private key, but we don't want that. So what we do is we add a arbitrary number to the seeds and then do the calculation again. We do it until it comes off the curve and it doesn't have a private key. So you can see that if it lies on the curve, it has a private key associated with that. But if it comes out of the curve, it doesn't have it. So we do the calculation until we find the address which lies outside the curve. So that is what PDA is, and PDS is a very important concept, and it is used extensively while doing transactions, doing programs, writing programs, and everything. So there can be two uses of PDS. One can be used as an escrow account, like how I explained, or else you can also use it as something called as hash maps. So the thing is, Rust has hash maps, but Solana doesn't let people define hash maps because that is computationally expensive and takes a lot of space. So to achieve that, what you have to do is you have to use a PDA. So you can have a PDA, and then you can have a PDA for different addresses, right? So what I can do is I can have PDF for each and every account, and I can have a data associated with that. So if you come here, I can create a PDF for storing venue, PDF for storing the ticket, and even PDF for storing the amount the person will put in for buying the ticket. So there can be many implementations. So, but what we are doing here, we're using PDF for only the key value pair, right? So we will create a key value pair between the key would be the venue ID and the value would be the PDA, of course. So we would need so now we are creating a PDA, and then we need to uh, so whenever you create a PDA or whenever you create an account, you initialize it. Initializing means that you specify the amount of token you need for storing this amount of data. So if you can see, this takes around 40. We can just make a 40 cap, and even this can have a 12, and then this would be the size of 40. This U64, it takes 8 bytes. This takes 8 bytes. So that is 40 plus 8, 56. And then this would take 32 bytes. So totally we need space of almost 40 plus 12 plus 12, 44, 84, 84 plus 56. So that comes around 138, 140, right? So you need to specify exactly 140 space, that is 140 bytes needed for initializing, and you should pay for that. So if you want to know how much it costs, you can just do Solana rent 140. So it says you need to pay 0.0018 Sol, right? So the payer should pay 0.0018 Sol to create a venue, right? Yeah. So we'll have that. We'll have the owner, and we'll have the seats. The a bump is what is an arbitrary number which is calculated so that the address doesn't lie on the curve. And space you need. So space I need is 12 plus 56 plus 32 plus we need something called as, okay, this is 56, But since it is a vector, so it can take multiple values. So I can cap it up to 10. So that makes it 560 and 32. Plus these are 8 extra bytes required for serializing and deserializing. And then we'll have an account, so I'll call it venue account. Okay. Also, we will have an account who will pay for it and he will sign the transaction. Okay. Yeah. So we will have owner, he'll be signer. That means that he will be signing with his public private key. Okay. And we'll have a system program. So system program is what does all the initializing stuff and all, right? So we will need this info, and then it is governed by the system. Okay. So good. Yeah, we don't have the venue ID, so we can import all these using instruction. Venue ID. Okay. Yeah, you need to provide the accounts structure we are passing, so it will be create venue and also the venue ID along with name. So name would be again string, and owner would be anywhere derived from that. Yeah. So you have venue account. So you should know one thing in Rust that all the variables you declare are by default immutable. So if I declare a variable called as this thing and I just do accounts dot venue account, so I'm so this okay, let's have U64. Okay. Don't know what's column. Let me have a look. I guess we can look at it later as well. Yeah. Yeah. So what I was saying is like all the data are immutable. So if you want a variable to be mutable, you need to specify the mut keyword. So this makes it mutable. Now you can change the data inside venue. So we would change the data as name, okay, and venue ID, venue dot owner. Yeah, owner we can get it from the accounts. Not available tickets are since they're not created yet. We'll just make empty vector for now. Yeah, so this is the initialization function. Yeah, we just change the name to create venue. Mm, this sounds good. Let's build this. Not build because this is an error, but we'll solve it anyhow.
So you just mentioned that a space equal to 40 plus 12. So that is the maximum cap, I think.
Yeah. So that is the amount of space you're paying for it.
Okay.
So
So
in some,
that is the maximum, or that is the correct.
yeah, I mean, the thing is, this 40 is anyhow, so we are taking 40. So the thing is, whatever the amount of space, whatever amount of data they are putting, it should not go above 5
Okay, okay,
amount we are defined, because you have to pay for it, right? So you can even define 2,000, 3,000, 4,000, whatever you want, but then that will be extremely high. And it has a maximum capacity of 10,000 only. So
okay,
this value cannot go above 10,000. So even that is a problem. So when you have something called pub key or basic types, you know that how much it would take, right? So this would take 8 bytes anyhow. If it has value 1 or 1 million or 10 million, 200
okay,
million, the value will still be 8 bytes. So here you don't have to do, but here you're guessing it 40. Here you're guessing
okay.
40. Here you're also guessing into 10. That you can be into 10 like that. But basic types, you know that it will take this much only, and I can have this much. You will know that. Okay, let's see. Yeah. mm, Okay, we can just search this error and find something. This is not the thing. Yes.
It is okay. You can just show your old program and explain it. That will be fine, I think. Because
Uh,
sometimes we learn
I
it's
mean, yeah, but this is the same thing which I'm doing. I'm wondering if doing something wrong.
so you explain your old program. That is fine.
But this is a different program.
Okay, okay, that is a different program.
That's why I'm not sure.
You just write and explain. And don't worry about the deployment and that part, compiling it.
Yeah, this is awesome. Let's see. Okay, awesome. Okay, great. So we'll write a small test for it. So what we'll do now is we'll write a function and then we'll create a test for it. As soon as we do that, so it just makes sure that we are on the right track. So what we'll do is first we'll create some of the wallets. So we'll create others. So I have this Alice account. I'll fund this. This wallet funded. And I'll just fund some salt for that. And this is a very good resource, Solana Cookbook. So we'll get each and everything what you need to do, right? So you can just go. I need to fund some Solana, right? I can go here. Mm-mm. Tokens. Let me check. And whatever you need, everything will be here. So you don't have to worry if you don't find anything. Okay, I'm not sure. Uh, I'll just check over here. Yeah, so I guess you need to have a. Okay. This is a provider which, so now we are using the environment which environment variable has the devnet. So local net for now, I guess. So we'll be using local net for doing all the transactions. Okay, we'll find a dot connection dot confirm transaction. And then here we need to fund. Okay, request airdrop. Wait, provider. Airdrop. And then so I can request two into lamp ports. So yes, and then I need to specify to whom I'm doing the airdrop. So it's imported from okay. Yeah. So the thing is, if you just hover over this, it will say that there are 1 billion lamp ports per sol. So Sol is the smallest. Lamports is the smallest entity for Solana, Sol coin. So the thing is, the lowest Sol you can have is 1 divided by 10 power 9. Since 10 power 9 equal to 1 billion. So now the wallet is funded. So if you just want to check if it has been happen or not, just do const balance is equal to connection get balance, and then you just provide your public key and just check if they're equal or not, right? Okay, let's run this. Yeah, so that means the wallet is getting funded. So now we need to create a venue. Create a venue. So before we create a venue here, if you just go through it, this is an account which you are passing, and this is an PDA. So we need to create a PDA now. So what we'll do is we'll have the venue PDA and the bump. Though we'll not be using the bump, it returns the bump value. So if you don't want to use it, just put semi what do you call underscore. We have an inbuilt function for getting the uh, PDA. So we'll be using find program address. So here the seeds contain two things. One would contain the seeds and the program ID. So if you have the same seeds, but the program ID is different, the PDA would be the different. That's why it's called program derived address. So the PDA, so the PDA account is derived from the program ID as well as the seeds. So seeds, you can see that I convert from so it's venue, and the other is B. So wallet ID, venue ID. So I can just do okay. Yeah. So now you have the PDA derived. That's all. Now you need to do a transaction. So you need to pass all the accounts. So I'm calling the methods. Method create venue. That's the only method we have. Pass venue ID along with the name. It would be my venue. Okay. So yeah, that's all it has. Okay. Now we'll be passing the accounts. Accounts will be venue account. So the thing you observe now here is, in this, if you see, there's a convention in Rust that all the variables should be named in what do you call a snake case. Okay, but the convention is in JavaScript is everything should be in camel case. So what it does is Anchor does the translation for you. So if it is in snake case over here, it will be in snake case, of course. You have to write it in camel case over here. So you can't write venue account. To write venue and capital A in this. So now it identifies the program, identifies the function. That's how it works. So venue account is a venue PDA, and then then we have the owner, the alias and public key, and then we have the system program. Now we have to pass a signer. So since we have a signer over here, we need to pass a signer. So what happens is, like, if you're having this in uh, if you're having this in website in the client side where you don't have the access to a private key, you sign it by a wallet. You don't have to put the signer. You're putting the signer now because we have the private key now. So this is a key pair. You have the public key as well as private key. Yeah, so that's why you do that. But in real world apps and all, you don't use signers. You just use a dot RPC, and it opens the wallet and you just sign it. Right? Yeah. Now it has been created. So let's check if this name is equal to what name we provided, and this venue ID is what we provided here. So let's do that. Wait, program the account. Account, we have only one account for now, and we have to fetch it. We have to pass a PDA account which is holding it. So account which is holding it is PDA account. Yeah. Now we'll just assert if venue dot is equal to, sorry, that's not equal, which is my venue, and then venue ID. Yeah, so then you have to write in everything is in camel case. You cannot use any case over here. Yeah, so let's run this. Yeah, so it's working. Awesome. Yeah, so now the next step, what we need to do is, if you want to check if it is working or not, just put another variable and just check if it is failing or not. If it fails, then good to go, or else something is wrong. Yeah, it's working. Yeah, okay. Amazing. So we'll have a next function which will create the tickets. So the ticket will have the name, right? So name, available, quantity available, and the price. Name would be the string, and then available would be the US64, and then price also be US64. Okay. So before we that, okay, let's again we'll create a PDF for that. No, actually we won't create a PDF. We'll just use the existing PDF because here we're not creating anything. We just fill. You just using this vector. So what we'll be doing, we'll be just pushing the new tickets over here. That's all. So we don't have to initialize it again. We just have to provide the seeds. So that would be the same as new. And then we would need the venue ID again. Bump, we need to pass it from the front end. So it will be venue bump. We don't have to define the space again because it's already created. So we should have an instruction. Okay, so we'll have same account. New. Okay, yeah. Now we just need the signer because we don't need a system program here because we're not initializing anything. So it doesn't make sense to have the system program. So we just have the signer and the owner. Yeah, but the problem here which we're not solving here is okay, you need to venue bump as well. Yeah. So the problem here is anybody can call the create tickets, right? So I can create a venue. It's my venue. So it's me who's gonna create the tickets. So it's not anybody else. So we need to have something. So we need to be able to do something that this function can be only called by the person who created this ticket, right? Yeah. So we can have has one and has one owner we can do. So what it does is this is a very important concept. So what it does is we have the owner variable over here and here as well. So this checks if this owner matches this owner. So this makes this function callable only by the person who has created this PDA or who has called this function, right? So if I create a venue, only I will be able to create tickets. Okay. Yeah. So since the account has been created, I will take the venue as reference. Okay, and then I'll create a new ticket. So, ticket. This is a way of creating a new structure. Okay. Yeah, it's just. So the thing is, if the key and the value are the same, you don't need to provide. You don't have to provide the key and all. You just have to provide the variables. That's enough. So what I need to do here is I need to venue dot variable tickets. So this will create a new new ticket over there, right? So then I can just go and then buy tickets and all those things, right? Okay, sounds good. Let's go and write this for it. Mm, create think again create a PDA, so we can just copy it or do it again and just copy it. Create a new transaction. Create a new object. Sorry. We need to pass the things we need. Oh, sorry. So the thing is, these instructions just corresponds to these things. Doesn't have to be the name. The name should not be the same. I mean, doesn't have to be the same. So what is happening now is this name is referring to this thing. So this venue ID is nothing but this name, and this venue bump is nothing but this one. So this will create an error when we run it. So what we need to do is we need to add the venue ID as well. And then venue bump. Okay, yeah. So this would solve it. So this would correspond to this thing. So since these are not used, you can just add an underscore. Yeah, so this will just tell the compiler that we won't be using these variables, right? Yeah, so let's start with this. So we will need the venue ID, venue bump, and then the name of the ticket. So this would be basic. I'll just do one thing. Nice. So we have defined everything. Okay. Let's remove these. So I'm done. Now we need the first ticket quantity and first ticket price. So you can see that so there's some error over here because the thing is these variables are in U64, but we're just passing it as it is. So what you need to do is if it is above U32, you need to pass it as a big number. So anchor has a function for that, so you can just use it, and that error will just go off. Okay. Mm-mm. Oh, sorry, we are using create architects. Let's build this. It's not referring because the ideal which resides over here. This thing needs to be updated, right? So when I do anchor build, this gets updated. Yeah. Now this gets to answer these things, right? Yeah. Counts. Okay. This is extra. So we need just two accounts. Venue account. Say the venue PDA. And then That would be Alice. Signet would be Alice. Okay, so remember the RPC is what calls the contract. So if you just run it without RPC, then it's no use. The call would never be made. Just have the state again. Okay. We'll have the venue as well. Let's yeah. So short dot state dot available tickets. Since this is the first one, and we know that we can just check if it's the same. Price, and then that would be, since these would be in a big number, we can just convert into string. Okay, let's run and check. Okay, okay, guess we missed something. Okay, so that's not quantity that's available. Yeah, awesome. So we have done two functions. So the last function is just purchasing the ticket. That's all, right? So let's do that. On purchase tickets. ID would need, when you bump would need, and then you just need the ticket name, because that's how we can identify the particular ticket, right? So we just need the name of the ticket. So ticket name. So yeah, and the quantity as well. So we need to have something for purchase ticket as well. Accounts. We need the same instructions. Um, purchase tickets. So here we're gonna create another PDA. Let me come back to that. I'll tell you why we need that. We won't need the has one because this can be called by any. So okay. Yeah. So we would need to create another account for this, another PDA to store another data structure which we're gonna be creating now. So let's create one because we need to be storing somewhere that this person owns the ticket, right? So we can just do purchase ticket, and then we can just write the ticket which he has purchased. So this should be of the type this thing and the quantity. So Okay, so we would be initializing a new PDA, so this makes sense. And anyways, payer would be the buyer, and then seats would be ticket. Then this would be we can take the venue ID and then also the buyer address as well. Okay. So since we're initializing, we don't need to give the bomb, but we need to specify the amount of space we're gonna be taking. So let's calculate that as well. So we would be needing 6 and 64. 64 plus 8, so 72. That is the amount of space we need for this. So whenever person creates wants to purchase a ticket, he has to pay 72. He has to pay for 72 bytes. So it's 56 plus 8 plus 8 for extra for doing deserialization now. So wait. Okay. So so this would be purchased. Okay, purchased ticket. Confusing kind of. So you're getting an error because we don't have a session program. We need a session program now because since we're doing the initialization of the program, right? So yeah, so we have a signer. Your account. Sorry. Okay. Sorry. So there are a couple of conditions you have to check before the person can purchase it. First, we need to check if there are available tickets or not, right? So you need to check. Yeah, first you need to find the index of the ticket which the person has to is going to buy. So yeah, let index is equal to, since this index would be changing its value, I'm defining as immutable. Now I need to define it as max value. Okay. Available tickets outline. Five. Yeah. Index is equal to I. Take. Simple enough. If index is still equal to usi.max, that means ticket name was not found at all, and then we need to return an error. That can be done by having a macro and so this is, you're getting an error because we don't have this particular. Okay, I guess. Yeah. So we don't have this particular enum, so we'll define this enum as well. we need to define it as a particular macro, and then PM error code. Then we can have invalid ticket. If you want to display a message, you can also display a message as well. Ticket list. So this will return an error if that something happens, and we can catch it in the front end and then show it to the user, right? So this makes sense. Yep. Great. Now, so now we just check if the ticket is not there. We return an error. Now we just have to check if the ticket is available or not. Let's do that. Mm, okay. So I'm doing a clone because the available tickets is not letting me copy it, right? So I have to clone it. Doesn't have, I mean, doesn't give me a mutable reference for that. And then since I'll be doing some changes, I need to have it mutable. So I need to add this as well, or else I won't be able to change the contents in the ticket, right? Yeah. So I don't think I would be. So maybe I don't need mutable reference. It's not. Maybe I need, yeah, to change the amount of quantity of the tickets. So let's check if get dot available is less than quantity done. So okay, yeah. So we also solved that. So the problem here is we have to do by this because we are using unsigned int. So we cannot subtract ticket available minus quantity and then check if it is less than zero. If it is less than zero, that would return an error which we don't want. So we can do this by just checking ticket available less than quantity. It's the same thing, but we can go with the other track because these are unsigned and then that would generate another error. Yeah, so these are the two things which we had to check and we have checked. So if it comes to here, that means it is legit and it is what the person wants. So we can take another reference. Tickets. Yep. So sorry. And it's account. Okay. Now purchase account, purchase tickets. Dot it has ticket and quantity. So ticket would be ticket, then purchased tickets, quantity would be quantity. Okay. I saw though. I don't need this. Now we need to minus some available tickets there, right? So we go to menu dot tickets of index dot available equal to. So we can just do uh, available tickets dot this thing available. So, so we need to subtract by quantity. Else. So this is just an error checking mechanism. Okay. Or else we have another. Okay. Then yeah. So this is just a safety mechanism. We can actually here it's actually safe to not use it, but then it's always a better way to use checked sub or checked add or checked div or something, because it checks if it's going underflow or overflow and returns an error as it is. So it saves you a lot of time, and then because later you don't know if it's going to overflow or underflow, right? So it's always to have this, right? Now, yeah, so we are done. Mm, let's create mm, test tickets. Mm, we need this again. Every time you need this, you can just have a global function that would just fetch all these, because having all these every time is, I mean, it's just repeating the code. So you wouldn't want to have this. For the time being, it's fine. And doing just have a utilization function which will all do this crap and all these things. So let's say get PDA. But here we have another thing which we have. Okay. So till now we have only one account, but we need another one, which is the buyer. We need to fund Bob as well. So we have two accounts now, Bob and Alice, and even Bob has been funded. So for us, okay, now the PD has been created. We just have to create. But since you're not using the transaction variable, we can just if you're getting confused, just do anchor build. So it will update the IDL and then you can use it to refer properly. Yeah. So what you need there? You will need venue ID, and then what else you need? Um, Nine accounts. Okay, so what you need venue accounts? Account is account. Your account would be then we need the buyer. Buyer would be Bob. Okay. And then we have the system program. Okay, dot system program. Uh, so yeah, so this should be in November. Okay. So we have signers. Let's see. Bob this time. Then RPC. So this is last step. We just have to check if we just have to check if the person is able to buy the ticket or not. That's all. Pass the ticket PDF. Okay. We just have to check if is equal to 10. Also check if the ticket is bought a same or not, but still, or we can do that as well. Uh, mm, if I'll be checking this, actually, yeah, this makes sense. Okay. We're done. Okay. Yeah. So this is the thing which we have built. So if you just go to the functionality, a person can create a venue, create tickets, and purchase tickets as well. It has all the following mechanisms. The one main thing which we are missing over here is purchasing ticket without paying. So I don't think we have time for that now, but I have the updated code with the prices as well. I will upload on my GitHub so you can have a look. Um, what we would do is we would create a new token, okay, using this create mint, and then after creating a token, we will mint some tokens to our account, and then while purchasing ticket, so we will multiply the quantity along with the price of the ticket, transfer it to the transfer to the venue owner, and then the ticket would be given. So if the transfer is unsuccessful, the buyer won't be able to buy the tickets. Yeah, I think that's it. Okay. Okay.
Okay. Hi, Dhruv. So
Hi.
it's done, right?
Yeah. I mean, the thing is, I
Almost.
wanted to do the
Uh,
transfer thing, but I think it took a lot of time for this. But
Okay.
we can do it on some other time because the main thing is
Yeah.
transferring the account from one account to other account. No, that's the basis. But
Okay.
I don't think we could do that now. But it
No,
would
we,
have been.
we, we don't need even, right? Okay.
Huh?
So yeah, we
Okay.
will cover in next session, right? So
Yeah.
this was just intro, and yeah, that is pretty much enough, for today, right? So I
Yes.
think people will be like see they will just consume it, right? So at least they will have basic knowledge of Solana, right? How to
Right.
start with. Yeah.
Yes.
So now we will, plan again. We will plan again. Few more, like one more session for next concept. Okay.
Yeah.
So,
Sure.
yeah, yeah, yeah. So, thank you so much, Dhruv. It means a lot for us and for our team as well, and the learners who joined the meeting and who joined the streaming and who will watch the posted video. So this will be a great help. Okay, because till now we never streamed any workshop on Solana, and this was our first ever. Okay, and yeah, like thank you once again.
Yeah. Thank you for having me. It was actually a nice thing. I guess
Yeah,
people. I mean, I guess I was able to explain the concepts properly. I
yeah,
mean,
like of course,
if you guys have
see
any
people.
doubts, put pitch in.
Yeah, of course. So, like I'll also share your, LinkedIn profile. Okay. And please do share that with me. Okay. So I think we are connected on LinkedIn. So please share that on LinkedIn. So I'll share that with people so that people can connect with you as well. Right.
Yeah. Sure. Sure. No problem. No
Yeah.
worries.
Yeah. So thank you once again, Dhruv. You know, yeah.
Yeah.
Good night then.
Goodbye. Bye. Bye.
Yeah. Good night. Bye.